Hello students, welcome to Bachelor of Science program, Subject Botany, Semester 5, Course Code BOD105, Course Title Nursery and Gardening. The title of this unit is Seed and the module name is Seed Dormancy, Causes and Methods of Breaking Dormancy. I am Ms. Aditi Venkatesh Naik, Assistant Professor from PS College of Arts and Science, Pharmakudi, Goa. The outline of this module, it comprises of seed dormancy and its causes and methods of breaking seed dormancy. What you will learn from this course, the student will be able to explain seed dormancy and state its causes. The student will be able to describe the methods of breaking seed dormancy. What is seed dormancy? Seed dormancy can be defined as the state or a condition in which seeds are prevented from germinating, even under the favorable environmental conditions for germination, which includes temperature, water, light, gas, seeds, and other mechanical restrictions. The main reason behind these conditions is that they require a period of rest before being capable of germination. And these conditions may vary in different plants, like from days to months and even can long up to years. These conditions are nothing but combinations of light, water, heat, gases, seed coats, and hormone structures. What are some of the causes of seed dormancy? Seed dormancy can be caused due to varying factors such as light, response to temperature, presence of hard seed coats, period after ripening, presence of inhibitors which prevent germination, immaturity of the seed embryo, the impermeability of the seed coat to water or to oxygen, the mechanical resistant seed coat, the presence of high concentrated solutes. Before we understand the methods of breaking seed dormancy, let us understand the types of seed dormancy. They are innate dormancy, enforced dormancy, and induced dormancy. Now, in innate dormancy, it is nothing but a condition of seeds which are incapable of germination, even if the conditions suitable for seedling growth are supplied. There is inability of germination, which may be due in certain species to the embryo being immature at the time of dispersal. Here we see that the plants possess innate dormancy because the embryos are immature at the time of dispersal. The next is enforced dormancy, which is a condition of seeds which are incapable of germination due to environmental restraint, which includes inadequate amount of moisture, oxygen, light, and suitable temperature. Because of the absence of adequate amount of factors which are responsible for germination, the plants or the seeds may show enforced dormancy. The third type is induced dormancy. This type of seed dormancy occurs when the seed has imbibed water but has been placed under extreme unfavorable conditions for germination. Though the seed has imbibed water and has been placed and later on placed under unfavorable conditions, the seed later on fails to germinate even under the more favorable conditions because the seed earlier was facing unfavorable conditions and had already imbibed water but was not exposed to the favorable conditions which forced the seed to show lack of germination under favorable conditions later on. There are various methods of breaking the seed dormancy, which are natural ways and artificial ways. The natural breaking of seed dormancy is nothing but the nature of dormancy which stops the embryo from getting appropriate environment such as adaptive moisture and temperature. The seed coat that exists in many species becomes permeable due to the rupturing of smoothing action of natural agents like microorganism, temperature, and aberration by the digestive tract of birds and animals that feed on these seeds. It is nothing but the exposure to environmental conditions or agents that bring about a rupturing of the seed coats, in most cases, which bring about dormancy in seeds. These natural methods include completion of overripening period, leaching of leaching of inhibitors which are present in the seed coat, the inactivation of inhibitors by the supply of cold, heat, and light which are present in the environment, the leaching of excess and highly concentrated solutes from the seeds, and production of plant growth hormones which can neutralize the effect of inhibitors. Let us now look at the artificial methods of overcoming seed dormancy. The seed dormancy can be broken by action with hot water for termination of waxes, surface inhibitors which are present on the seed coat. Rupturing of seed coats by filing, chipping, and threshing through machines. Exposure to light, cold or light. Exposure to heat, cold or light, which depends upon the type of seed dormancy. By applying pressure, that is hydraulic pressure, for around 5 to 20 minutes in order to weaken the tough seed coats. And another method is seed coats can be treated with concentrated sulfuric acid for removing all the traces of the mineral acid. Now, this is an image which shows that there is a seed which has a hard seed coat. The seed covering provides physical restraint against the radical protrusion. The seeds remain dormant as long as the physical restraint exceeds the pushing force of the radical, which is related to the embryo's growth potential. Now, because of this presence of intact seed coat, the radical is not allowed to come out from the seed coat and thus brings about dormancy in the seeds. So, here the dormancy can be released, which involves a reduction in the physical restraint. Now, in this case, the physical restraint is the seed coat from the seed coverings along with the increase in the potential growth of the embryo. Now, let us look at the treatments that can be utilized to break the seed dormancy. The most important factor that brings about seed dormancy in seeds is the presence of a hard seed coat. So, the method that can be employed is by softening the seed coat and other seed coverings. Several methods are used for breaking the seed dormancy, which helps in better absorption of water and gases, which ultimately leads to better germination of the seeds. And this can be achieved by sclarification. Sclarification is nothing but a process of breaking, scratching, mechanically altering or softening the seed covering, which makes it permeable to water and gases. Three types of treatments are commonly used for sclarification treatments, which includes mechanical, chemical, and hot water treatments. Now let us look at each of these carefully. In mechanical sclarification, it is a very simple and effective means if suitable equipment is available. Chipping hard seed coat by rubbing with sandpaper, cutting with a file, or crackling with a hammer are simple methods that can be used for small amount of relatively large seeds. However, for large scale breaking of dormancy, mechanical sclarifiers are used. Here, the seeds can be tumbled in drums which are lined with sandpaper or in concrete mixtures containing coarse sand or gravel. The sand gravel should be of different size than the seed to facilitate subsequent separation. Sclarification here, that is mechanical sclarification, should not proceed to the point at which the seeds are injured or the inner parts of the seed are exposed. Now let us look at the acid sclarification. From the term itself, we come to know that sclarification is achieved or the process of breaking the seed coat is achieved by the utilization of acids. Here the dry seeds are placed in containers and covered with concentrated sulfuric acid or HCl, that is hydrochloric acid, in the ratio of 1 part of seed to 2 parts of acid. The amount of seed treated at any time should be restricted to not more than 10 kgs to avoid uncontrollable heating. The container should be of glass because we are using acid, earthenware or wood, non-metal. The mixture should be stirred cautiously at intervals during the treatment to produce uniform results. Here the time may vary from 10 minutes to 6 hours, which depends upon the type of plant species we are using to break the seed coat. With thick coated seeds that require long periods, the process of sclarification may be judged by drawing out samples at intervals and checking the thickness of the seed coat. When it becomes paper thin, the treatment should be terminated immediately. At the end of the treatment period, the acid is poured off and the seeds are washed in order to get rid of excess acid or complete removal of acid on the seed surface. The acid treated seeds can either be planted immediately when wet or dried, or they can be stored for later planting. Last seeds of most legume species like brinjal and tomatoes are reported to respond simple sulfuric acid treatment. Now let us look at hot water scarification. Here the seeds are dropped into 4 to 5 times their volume in hot water with temperature which ranges above 70 degrees Celsius to around 100 degrees Celsius. The seeds are soaked in a gradually cooking water for 12 to 24 hours. Following this, the unswollen seeds may be discarded or separated from the swollen seeds by suitable screens. The seeds should be sown immediately after the hot water treatment because here we are using water. It is essential that we immediately sow the seeds in order to avoid any contamination of the seeds. Next is warm moist sclarification. Here the seeds are placed in moist warm medium for many months to soften the seed coat and other seed coverings through microbial activity. Now, this treatment is highly beneficial in seeds which have double seed dormancy, that is, seeds which show combination of seed coat dormancy, which is linked to combination of seed coat, that is external dormancy, as well as internal dormancy, that is, which need sclarification as well as stratification methods. Here, the hard seed coats are planted in summer or early fall when the soil temperature is still higher. That usually facilitates germination. The next method is stratification, which is referred to as the internal dormancy, which shows delayed germination, which is an important function of seed dormancy because it allows dispersal and prevents all seeds from germinating at the same time. Stratification is a method of handling dormant seed to a range of processes, that is, they are given pre-treatments which are used to stimulate natural conditions like temperature and moisture that seeds require before germination can occur. It is nothing but the method of handling dormant seeds in which the imbibed seeds are subjected to a period of chilling after the ripening of the embryo in alternate layers of sand or soil for a specific period. Now, this methodology is referred to as the moist chilling. Now, let us look at the various ways of showing stratification or employing stratification methods. One way is outdoor stratification. When refrigerated storage facilities are not available, the outdoor stratification method can be employed, which can be done either by storing the seeds in open field conditions, in deep pits, or in raised beds which are enclosed on wooden frames. However, it is likely that the seeds are destroyed in outdoors by excessive rain, freezing, drying, or by rodents. Therefore, the seeds are placed in alternate layers of sand to provide and low temperatures and proper aeration in the stratification pit. The top layer is covered here with sphagnum moss to maintain the moisture level. The pit or the tray is irrigated at regular intervals to maintain appropriate moisture status. The next stratification method is refrigerated stratification. This is an alternative to outdoor field stratification and is referred to as the refrigerated stratification, which from the name itself suggests the need of refrigeration. It is useful for small seed lots of valuable seeds that require special handling. Here, the dry seeds should be fully imbibed with water prior to refrigerated stratification. Here, 12 to 24 hours of soaking at warm temperature may be sufficient for seeds having or lacking the hard seed coat. After soaking, the seeds are usually placed in a convenient box in alternate layers of well washed sand, pit moss, or vermiculite. A good medium for this is a mixture which contains 1 part of coarse sand to 1 part of peat, moistened and allowed to stand for 24 hours before use. The seeds are placed in alternate layers of sand or medium. The usual stratification temperature that is employed in this methodology is around 4 to 7 degrees Celsius. At higher temperature, the seeds sprout prematurely and low temperatures delay sprouting. The next method is leaching of inhibitors. Now, this is established fact that some inhibitors of phenolic compounds which are present in the seed coverings of many species inhibit germination. Therefore, it is essential that soaking of seeds in running water for 12 to 24 hours and placing them in water for few hours, which helps in leaching of the inhibitors and phenolic compounds. Now, these compounds which are present in the seed coat inhibit germination, and hence it is required to get rid of these inhibitors or phenolic compounds which help in easy seed germination. The next method is pre-chilling. From the name itself, it means chilling. That means before germination, you have to give a chilling treatment. In seeds of certain plant species, dormancy can be overcome by pre-chilling treatment. In this treatment, the imbibed or the soaked seeds are kept at a temperature of 5 to 10 degrees Celsius for 5 to 7 days before sowing. After that, the seed can be sown in the field immediately. The next method is pre-drying. Now, this is again a useful practice in some seeds to overcome seed dormancy. Now, in this treatment, the dry seeds are subjected to a temperature of around 37 to 40 degrees Celsius for 5 to 7 days prior to sowing. After this, the seeds can be sown in the field. The next method is seed priming. Now, seed priming refers to the procedures that are followed to overcome dormancy that occur in freshly harvested fruits. Most widely used seed priming procedures include osmoconditioning, infusion, fluid drilling, etc. Like, for example, let us consider osmoconditioning. Here, the seeds are placed in a shallow layer, which in a container which has around 20 to 30% solution of polyglycol, that is PEG. The seeds here are incubated at 15 to 20 degrees for 7 to 21 days, depending upon the seed size and plant species. In this method, different hormones and fungicides can also be added so that it serves as a protection to the seeds from pathogens. After this, the seeds are washed and dried at 25 degrees Celsius and stored until further use. The next method is chemical treatment or treatment with chemicals. Now, some compounds other than hormones are also used to break dormancy, but their role is not very clear. For example, when we see thiourea is one such example which is known to stimulate germination in some kinds of dormant seeds. Here the seeds are soaked in 0.5 to 3% solution of thiourea for 3 to 5 minutes. Afterwards, the seeds are rinsed with water and are sown in the field. Similarly, potassium nitrate and sodium hypochlorite are two other chemicals which can help in stimulating seed germination in many plant species. The last methodology which can be used for stratification or breaking the internal dormancy is hormonal treatment. Among various hormones, it is seen that gibberellic acid is commercially used for breaking the seed dormancy in different types of seeds. Cytokinin is another group of hormones that can be used for breaking the physiological dormancy and also for stimulating germination in seeds. Kinetin and benzyl aminopurine, that is BAP, are commercial preparations of cytokinin which are often been used for breaking the seed dormancy. Let us summarize what we have learned. Dormancy refers to occurs when the seeds or tubers do not germinate despite the availability of essential conditions like temperature, humidity, oxygen, and light conditions. The dormancy is caused by impermeability of the hard seed coat or a lack of availability and activity of enzymes which are crucial for germination. In order to break dormancy, the organic material or the seeds are subjected to a series of physical and chemical pre-treatment in order to soften the seed coat and other seed coverings. Delayed germination is a key aspect of seed dormancy. Because of this, it facilitates dissemination while preventing all the seeds from germinating at the same time. These are few references that you can refer to. Thank you so much.